So now vehicle automation and self-driving cars are all the rage, right? Tesla, for example, has largely adopted lots of features of complete automation. Some people claim by 2025 the market will be full of self-driving cars. Uber was trying for many years to do something, but apparently is going to sell it off and maybe give up and wait for others to work on it. Nonetheless, we will look at potential energy and emissions impact of automated technology. The upper bound case is shown in the first slide I'll go back to, and the lower bound case is shown in this panel, which we'll come back to. Okay, so here is the baseline to 0%. Hunt for parking. So when a car is self-driving, people may tend to be more generous in driving around looking for parking. Whereas if you have to drive yourself, you're going to get tired and try to avoid driving to places where parking would be difficult. Okay, easier travel, of course, it's going to have a huge benefit. Underserved communities, for example, handicapped people or blind people, I don't know. So maybe that's what this refers to in terms of advantage. Mode shift, ride sharing could be a huge benefit when you are when you have a automated vehicle, so that nobody has to argue about who's going to drive. The car is going to drive itself. Empty miles probably are going to increase. That's not going to be a good thing, because automation is expected to increase people's tendencies to make short trips, run errands. For example, hybrid cars tended to increase people's driving vehicle miles, because they thought they're being environmentally friendly and consuming less gasoline, emitting less, and they tended to drive a little more than they would otherwise in a normal car. In terms of efficiency, drive smoothing, somewhere in this range, and faster travel, intersection vehicle to infrastructure communication, collisions avoidance. Platooning is basically connecting, let's say, multiple trucks with these automation softwares so that they can travel together, synchronize, and be very efficient in their travel and vehicle miles traveled, emissions, fuel usage, and so on. Vehicle resizing, again, upper end of the positive benefit. On the lower end, so you go to 0% and look around the lowest possible benefits and negative impacts you would have. So hunt for parking is still negative. Ease of travel in the lower end is probably going to be plus minus. Underserved, sorry. Mode shift, ride sharing, empty miles. And in terms of efficiency, maybe drive smoothing will reduce efficiency by up to 20% or more. Faster travel could be negative as well. Intersection V2I, collision avoidance, resizing. Anyway, I'm not going to go into the details. You have to look up this paper. But the main point is that just like the efforts to downsize or reduce congestion by increasing roadside would have some negative impact, like latent drivers coming out thinking now there is a bigger road and less congestion. Automation will also have many benefits, but also many potentially negative outcomes. Okay, the early conclusions regarding automated vehicles include these things. Partial and full automation can reduce energy use and emissions, but only if incentives exist to encourage pooled use of vehicles. So this is the idea of driving more because you have a self-driving car. You don't feel so tired, and you think you can just hop in the car and run errands because the car is going to drive itself anyways. Automated vehicles that communicate and coordinate with other vehicles and the infrastructure, the V2I, will likely have greater improvements in safety, mobility, and the environment compared with autonomous vehicles without those capabilities. Okay, so safety is argued to be one of the big things, mobility of course, and the greater improvements in the environment. Automated vehicles have the strong potential to induce travel demand. This is a negative thing, unless again incentives exist for pooled use of vehicles. Okay, so there is always the potential for unintended consequences. It may be advantageous to first introduce automation in fleet applications like taxis, buses, or shared mobility, since their operations, that is total travel, can be closely managed and pooling can be more easily encouraged. Like Uber, for example, has a Uber Pool option where you can save money by sharing the ride, and the ride app apparently can minimize the routing of the driver, the Uber driver. Okay. Air conditioning is another big energy consumer in the cars, can be up to 20% depending on the size of the car, the weather you live in, the season, etc. So lifetime greenhouse gas emissions from mobile air conditioning in terms of kilograms carbon CO2 equivalent, high average temperature conditions. So it's a specific period that has been calculated. So this is greenhouse gas reduction potential from an internal combustion engine passenger vehicle, air conditioner operating at higher average temperature conditions, such as those found in Florida, which is basically a tropical country with high humidity and so on. So in terms of the HFCs that are used, R134A is the most common one with a greenhouse warming potential of almost 1,300 times that of CO2 over a period of 100 years, I think, and also has a fairly long residence time. So there are enhanced R134A which are much more efficient. So compared to the non-enhanced HFC use, there could be a saving of 44% in terms of lifetime greenhouse gas emissions. Reduced load would further reduce it by another 15%, sorry. Powertrain optimization, that's vehicle technology. Non-refrigerant, so that's an option there which could further reduce it to by 7%. So these are indirect high and direct high, which are kind of the benefits that accrue from direct benefits or indirect benefits, and these are the high estimates of the given conditions. Okay, so this is a short chapter, but we basically got few takeaway key points in these. Transportation plays a crucial role in energy use, greenhouse gas emissions, and local air quality. This is very clear already since the 1940s. There are generally 4 different ways to mitigate transportation emissions through vehicle technology, low carbon fuels, vehicle miles traveled management, and intelligent transportation systems, including use of connected and automated vehicles. So that platooning idea there. Vehicle electrification is well underway and is providing opportunities for large emissions reductions, but as we said, incentives will be needed to reduce unnecessary extra miles, latent driving to emerge because of the automation. Huge improvements in vehicle technology have reduced pollutant emissions and to a lesser extent CO2 emission. The amount of vehicle use has increased dramatically over the last several decades and has a significant role in transportation emissions. So there is a kind of move towards owning cars and using cars, especially in the US because of the problems of public transportation, and people moving to suburbs, driving in, commuting to work, developers not really staying on top of the mixed land use kind of planning and so on. So it's a kind of a catch-22 with also some lobbying from auto industry involved in there. VMT can be reduced, vehicle miles traveled can be reduced by increasing the use of pooled travel. For example, buses, transit, shared mobility that is pooled. Other VMT reduction methods may include adopting incentives and disincentives to reflect full social costs of travel. Social costs again is for each additional mile you travel, how much you emit, how much harm you cause to the third party in terms of emission impacts, noise, whatever else. And eventually transitioning from individual vehicle ownership to use of mobility services that are pooled. Imagine nobody owns cars and everybody is carpooling or sharing rides. Like Uber and Lyft and so on. Sustainable transportation requires advances in all aspects of transportation, of course, including technological, political, economic, and behavioral aspects. Especially in the US, this political aspect is a big player, unlike Europe, where these changes tend to be easier. There are social science theories about why the US is so different. When it comes to environmental awareness, activities, actions, willingness to pay tax, related climate change denial, and so on, but we won't go into that here. Vehicle automation is likely to be deployed in the near future. It's pretty much guaranteed. It's a train that has already left the station, so things are already going in that direction, and there is no going back, and should be managed so as to achieve environmental sustainability. So all the unintended consequences need to be avoided desperately as this technology begins to dominate. Just think about Industrial Revolution and all the conveniences that came with it have brought us global warming, and now if vehicle automation also begins to bring more environmental harm than good, then obviously a careful monitoring and action is needed, incentivizing with the policies we talked about in terms of command-based and market-based and so on. Okay, that's the end of this chapter. Hopefully we got some good key points about sustainable transportation approaches.